Let us understand differentiability of a continuous piecewise function in this particular video. Enjoy the journey of learning. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos, taking keen interest, and making some great suggestions. Here is a video which is the result of your feedback. In this video, we are going to understand differentiability for a piecewise function. So, that is of major concern. Most examples give very obvious questions, and therefore, this concept is not much appreciated. So, we have four questions here, two of them right before you, and then similar looking two more. The idea is to understand the concept, apply it effectively to solve any question which is based on differentiability of piecewise functions. I hope it makes sense. Now let's look into the first two examples. Explain if the following functions are differentiable or not. So just a general statement, so we'll assume that the domain is of all the real numbers. Question 1, f of x equals to x squared plus 4, where x is less than or equal to 0, and x plus 4 when x is greater than 0. The next one, very similar, but what we have done here is written f of x as 3x squared plus 4 when x is less than or equal to 0, and just 4 for x greater than 0. Now the function will be differentiable. For that we have to look into few things. One, it should be continuous, right? So first thing, for being differentiable, it should be also continuous. Now how can it be continuous? So let's find the value of the function f of x as x is equal to 0 from the left side. So from the left side means I'm writing minus. So when we look at it from the left side, we are on the curve x squared plus 4, right? So there, if I substitute 0, we are looking into the function x squared plus 4, right? And it is equal to 4. Now let's also look into this particular function when x is approaching from the right side, means x is greater than 0. So in that case, we are looking at the function x plus 4, and when x is 0, this is also 4. So that means it is continuous. So first part we have done correctly. It is continuous. Now second one here also, if you check, you will find that the value of the function is also equal to the, let me write 0 here, right? Value of the function at 0 makes sense, right? And value of the function at 0 when you approach from the left side, and also when you approach from the right hand side, they are all equal, right? So in this particular case, if I substitute 0, we get the result as 4, just as we got in the last case. So that means the function is continuous. Now we have to figure out whether it is differentiable or not. For that, what is the concept? The concept for that is that the derivative, when we are approaching 0 from the left side, should also be equal to the derivative when we are approaching 0 from the right side. So that is the concept. It is continuous. But is the gradient same from both the sides or not? That is the key thing, right? Only then it could be differentiable. If this gradient is not the same, then it will not be differentiable. Perfect. So now let's analyze the gradient for this particular question. Makes sense, right? So I hope the concept is clear. Well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute at gmail.com. Our students are right there on the top since they have very clear concepts and they know exactly what they are doing. Okay, so we have verified one thing, that in these cases the function f of x is actually is continuous, right? How did we do that? We did that by proving that the value of the function at 0, because they are continuous otherwise in the domain, both the functions parabola and linear function, right? We also found that the value of the function when you approach 0 from the left side is also equal to the value of the function when you approach 0 from the right side. And all these values, if you put x as 0, is actually 4. So both the functions are continuous. Both are continuous. So now let's check for derivatives, right? So let me now divide this into two parts, two different questions. We'll solve one by one. So for first, what is the derivative of this particular function when we are approaching 0 from the left side? So the derivative is 2x, correct? So this is when x is less than equal to 2. So if I substitute 0 here, I get this as 0. That means it is a horizontal tangent. On the other side, if you want to find the derivative of x, it is equal to, for this wing, it is equal to 1, right? When x is greater than 0, which is a constant. So, so this derivative at 0 from the right hand side is equal to 1, right? So you see that the derivatives from the left side and the right hand side are not equal, right? 0 and 1, and therefore this function is not differentiable. You get the idea? Now let's look into the second question, because these derivatives were not seen. So in the second case, if I find the derivative of this particular function for x less than equal to 0, I get what? I get this derivative as equal to 3 times 2, 6, 6x. Now this derivative at 0 is what? So if I substitute 0 here, I get 0 only. Perfect. So from the left side, the derivative is 0 for 3x square plus 4. Now let's check it from the right side. From the right side, the function derivative is equal to derivative of 4, which is also 0. Correct? This is when x is greater than 0, because the function is 4, a constant. And what you notice that the derivative for this function from the right hand side is actually equal to 0. So when the derivative of this from the left side is equal to the derivative from the right hand side at a given point, which is 0, same, then the function is differentiable. You get the idea. Perfect. So that is how you do it. So I think the concept is absolutely clear, right? Let's take another question just to be double sure about it. So in this case again, I have taken same question, right, with slight variation. This time we're checking at a point which is near x equals to 1, right? So first let's check the continuity of this function. So what is the value of this function when you approach 1 from the left side? Means you will put the value in the arm which is x square plus 4. So here it will be 1 square plus 4, which is equal to 5. And also check what happens when you approach 1 from the right hand side. So in that case, it is 1 plus 4, which is equal to 5, correct? So definitely it is continuous. So that part is done. So now we have to check the differentiability, right? So first part is there. If it is not continuous, it cannot be differentiable. Perfect. Great. So now let's check the derivative of this function at x when when x is less than equal to 1. So upper arm, right? So derivative will be 2x. So let's put it like this. At 1, but from the left side, is 2 times 1, which is 2. So the derivative is 2. Now let's check the derivative when we are taking it from the right hand side. So derivative for x where x is greater than 1, x plus 4 we have to now look into, which is 1. It is a constant and it is not 2, right? So what we see that the derivative from the left side is not equal to the derivative from the right hand side. So therefore, this is not differentiable. Correct? Is that clear? Let's look into the second example. Now the first term is exactly same and therefore we know that the derivative of this function when you are approaching 1 from the left side is 2, right? As we did here. Let's check it from the right hand side. So the right hand function f of x is equals to 2x plus 3 when x is greater than 1 and the derivative of this function is 2, right? Which is a constant. So what we notice is that the derivative, this is when x is greater than 1. So we have found that the derivative at 1 from the left side is equal to the derivative at 1 from the right hand side and both are equal to 1 and therefore this function is differentiable. Makes sense, right? So you have to calculate the derivatives to get to the result. Well, if it was like a absolute value function, cusp and corners is very easy to do. But in this case, it is not that simple. Let me show you this particular case in a graph. So same example, what I've done here is sketch this graph of the arm x squared plus 4 when x is less than equal to 1, which is the red graph. You see that? Now, till 1, in both the cases, we are looking into a parabola, which is x squared plus 4. But after 1, we have two straight lines. As you can see, the graph which is on the top, which is represented with a steeper slope of 2x plus 3, is kind of continuous. You see that? That common tangent we have, right? So in this case, we have a common tangent. And therefore it is differentiable, right? At that point we have a common tangent and therefore it is differentiable. In the other case you can see that the slope is different, right? So here what we notice is that the green graph, right, slope is different and therefore it is not continuous. You get the whole idea, right? Differentiable, right? So this is differentiable and this is not differentiable. I hope it makes sense, right? Well, feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.